All right, guys. So today we are going to talk about creating the rule. So make a note of that, and hopefully we will. We'll do well with this. This is 3.2. It goes along with our parent function stuff. And so we're going to be using parent functions a lot, and we will be graphing with them. Okay. So we're going to talk about creating the rule to make nice tables that we can graph with. So when we make our rule, I'm going to give you a function. And I think the most difficult part about this is determining inside versus outside. So since this isn't under the square root, this is an outside thing happening. Okay. So you also need to determine the parent. So the parent function on this one is the square root of x. So I am going to write down the table for square root of x. If you don't know where it is, actually you have it in your notes because you copied it down. So the square root of x is the table that goes like this. Okay, so hopefully you copied that down. Now we're going to use the rule to transform a new table to be able to graph a new child function. So the rule is, this is my weird note for the rule. Whatever happens inside, I can erase that. Whatever happens inside goes opposite to the x's, and outside goes to the y's. Okay, so you're going to look at this and think, okay, is something go inside or something outside? The 2 is on the outside. So nothing is going to happen to the x's. So the x's are going to stay exactly the same, and I'm going to copy this over. 0, 1, 4, 9. What's happening outside the function is the +2, and that's going to go to the y's. I'm going to take these y's right here, and I'm going to add 2 to all of them. And I'm going to put that in my new table. So it's over here. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. This is the new table for my new function. And if I was to sketch a graph, which it's not going to be perfect because I don't have graph paper, but if you do, my original one would look like this. And I could use my table that I just transformed to plot my new points. 0, 2, 1, 3, 4, 4, 9, 5. And I would have a new graph that looks like this. So we're making the rule. The rule is to transform the table. I have a real lag going on here. Okay, so you're just transforming the table every time. And of course, I'll give you another one. I think I can just go to a new page, I think. New drawing. All right. So my new, if it gets there, my second example is going to be y equals the square root of x minus 4. Okay, so now that I've got this one, my parent function is the first thing I should think about. And that's y equals the square root of x. I'm going to copy down the parent table. Remember, I will always give you the parent table. It's the same as before. 0, 1, 4, 9, and then 0, 1, 2, 3. And now I'm going to go with my rule again. And that's whatever's happening inside goes opposite to the x's. Well, inside this time, I have this. I have a minus 4. So I'm going to go x, opposite of minus, is plus. What's happening outside? Well, nothing is happening on the outside. So the y's are going to stay the same. Okay. So this is my rule, and now I'm going to use my rule to make a new table. Okay. Instead of 0, I'm going to take all of these and add 4 to them, because that's what my rule told me to do. Take all the x's and add 4. So 0 plus 4, oops, I need to erase that. 0 plus 4 is 4. 1 plus 4 is 5. 4 plus 4 is 8. And let's see. What do I get here? 13. 9 plus 4 is 13. And then I'm going to copy down my y's because I'm not changing them, because there's nothing happening on the outside. So again, if I were to draw a picture, which I don't have any graph paper on here, my new one would start 0, 4 over and 0 up, and it would be shift over this way because this is 4 comma 0. Okay, so if you're remembering from yesterday, we talked about inside goes opposite. This one moves right 4 units. And sometimes it's easier to see once you draw it. Like we can see that this is moving right 4 units, and we could therefore graph it a lot better than we did before. Okay, so I'm going to do one of them that now has 2 things happening to it, so we can kind of do the rule to both the x's and the y's. Okay, so my new one will be the square root of x plus 3 minus 1. Okay, so I'm using the same parent function as before. I hope you noticed that. So parent is y equals the square root of x. So I can copy that same parent table down again. 0, 1, 4, 9, 0, 1, 2, 3. I will always give this to you. Don't worry about that. Now, what's happening on the inside? On the inside, I'm adding 3. So in my rule, I'm going to take all my x's and do the opposite. I'm going to subtract 3. On the outside, this one's not underneath that square root symbol. I'm going to take my y's and subtract 1. Whatever happens on the outside goes directly to the y's. Inside is opposite. Okay, so now when I make my new table, I'm going to take all of my x's and subtract 3. Okay, so I get minus 3, minus 2, 1, and 6. And then I'm going to take all my y's and subtract 1. So I get negative 1, 0, 1, 2. And if you were to graph this, you would find that the inside makes a shift to the left 3 units, and that outside piece moves down 1 unit. So graphing this, here's my original, would move left 3 and down 1, and then still have like the same graph kind of like this. You hopefully are going to do better when you plot it. So the point of this is to be able to graph a transformation of a function. And by transformation, I mean move left, right, up, and down, stretch, shrink, what direction, all that kind of stuff. So every time what you need to do, if I had to write steps, somebody told me they liked steps. So, sorry, I'm going to get a new one. The steps would be number 1, determine parent function. Okay, and the parent function comes from that list that you took notes yesterday. You have them all. You have a picture of them all. Okay, number 2 would be find the rule. Remembering that what happens inside goes opposite to the x. Whatever's outside goes to the y. Okay, directly to the y. 3 would be to transform your table. Okay, you're not doing anything with the original equation anymore. You're just transforming the table. Then 4 would be to graph.